This is the Nebraska Department of Transportation Asphalt Field Technician Training. This training is produced by the Materials and Research Division, Flexible Pavements, and Quality Assurance Section. I first want to welcome you. My name is Amanda Schinkel, and I will be narrating this training. If you have any questions, please contact the Materials and Research Section at 402-479-4697. This online training is taken at your own pace. It consists of 2 videos. I recommend that you take notes during this presentation, as you will be tested for certification and the exam is open notes. A pretest is required to register for the final exam. You can complete this pretest while watching this presentation, so I recommend that you have a copy of the pretest next to you during the training. After you have completed the online training and pretest, you must submit the pretest to NDOT for review by contacting the Materials and Research Division at 402-479-4697 to ask for the Asphalt Field Technician Trainer. After your pretest is reviewed, you will be given a date and a time that you must attend an online proctored exam for the certification testing. This will be administered through WebEx, and you must have an operational camera and microphone during the test. You will be allotted up to 1.5 hours, but it usually takes approximately 30 minutes to complete the test. You must pass the exam with a score of 80% or higher. The Nebraska DOT provides 2 training certifications for the hot mix asphalt. The first one is the Quality Assurance Quality Control Laboratory Technician Training, held in the spring of each year. That training is specifically for laboratory testing technicians. The other training provided by the Nebraska DOT is this training, the Asphalt Field Technician 1 and 2. This training is divided into 7 modules. Module 1 is a basic introduction to materials testing and sampling. Module 2 is an introduction to asphalt materials and plant production. Module 3 covers laydown, paving, and compaction. Module 4 shows you how to sample binder and emulsions. Module 5 is roadway sampling, sampling of hot mix, and density core sampling. Module 6 includes documentation of testing and production records. And finally, Module 7 covers a variety of paving topics. In this video presentation, I will be covering Modules 1 through 3. In the second video presentation, it will cover Modules 4 through 7. Here's a quick list of quality assurance personnel contacts for each district. For any questions that you may have pertaining to quality assurance once you start implementing your knowledge and skills to the job sites, contact the following. This is a list of contacts within the Materials Research Division if any other questions arise. Upon successful completion, you will receive NDOT certifications for binder and emulsion sampling and the Asphalt Field Technician 1 and 2. Let's begin the Module 1 training, Intro to Materials, Tests, and Sampling. Here we will go over specifications, plans, special provisions, and their hierarchy, lists, manuals, and locations of other supporting documentation, sampling, custody of samples, and sample identification. This slide shows a set of plans in the middle, the standard spec book to the left, and the project contract special provisions to the right. The hierarchy of these documents are: the special provisions overrule the plans and standard specs, and then the plans overrule the standard spec. You will reference this often and is a must to define, as there are sections that overlap in each, and must dictate how the contract is administered and interpreted. If you cannot clarify a question or discrepancy, discuss with your district management through your project manager, district construction engineer or assistant district construction engineer, district engineer, then the construction office. Now let's take a quick look at a set of plans. This is the title sheet that gives all the project location information. This is the North Platte East project. On this sheet you will find the project number, control number, the index of sheets, and the limits of the project. The next set of sheets in the plans are called the typical cross sections. Here, let me blow up one of these sections so you can see it better. This is where you will see the designed build of the roadway sections. You will find information such as the pavement thickness, milling depth, lane widths, shoulder widths, and much other vital information. The next sheet in the plan set is the summary of quantities. Each type of work has its own group. For example, you see Group 1's grading, Group 5 seeding, and Group 9 bituminous surfacing. This training focuses on Group 9 bituminous surfacing items. Here you will find what type of mixes are needed for each project, how many tons are calculated for each type of mix, and how much binder and tonnage is estimated. In Module 6, we will further discuss how to keep track of the tonnage on the job site. There are many other supporting documents that will support you during your project construction. Most can be found online or a PDF that can be sent to you from the originating division. So let's take a look at what you can find online. You simply need to go to the NDOT website that anyone can easily access, dot.nebraska.gov. Here you can find standard specifications, material sampling guide, approved producers, approved products list, lettings, projects, rules and regulations, and lots more. So now I will show you how to get to the material sampling guide, or MSG. In the upper right of the website, most of the manuals I showed you are found in the Business Center that is circled in red. We have selected the Business Center. Now select the Materials selection from the drop-down menu. You will then get this screen. On the middle left of the screen, select Materials Sampling Guide. With the Material Sampling Guide screen, you can select the MSG version relative to the date of the project. The MSG that applies to the contract is the one with the most recent date before the letting of your project. This is a screenshot of a typical table you will find in the MSG. It shows the material type, the type of test, the size of the sample, and whom is responsible for testing and acceptance of the material. This table provides all of the information on sample size, frequency, sampler's responsibility, and how the material is accepted. Now let's go back to the materials screen and select the approved products list on the left side, also known as the APL. Here is the approved products list screen. Here you will select the specific material applications to see what products are approved for use. Let's go through an example. Say for example that the plans call for a grade 1 epoxy, class B and C for the application. Okay, so you go out to the project and the contractor has this on the project, Sicador 35 High Mod LV, and wants to know if it is the correct material. We need to go to the approved products list. On the materials screen, select the approved products list. And you end up on the APL screen like this. Then click on this drop-down window. It will then open this window to choose the category. In this case, choose the concrete selection. Select the material from the list. You will get this screen, then select the Epoxy Resin Bonding System Grade 1 from the list. This will provide you a table with the list of the approved products. Go down the list and find the product that is approved for those applications. In this example, the contractor has the correct material for use. Okay, now we're going to shift gears and take a large overview of sampling, custody of samples, and sample identification for some of our most common materials such as soils, aggregates, asphalt, performance graded binders or PG binders, emulsions, Portland cement, asphalt and concrete pavement cores, steel, and precast components. First, let's look at why we sample and why it's so critical. There are two key reasons as to why we sample the test and the material or products. Number one, to test or verify that we have the correct quality of material. Number two, to verify that the material is being tested accurately. So essentially, NDOT is testing the tester and testing the equipment to provide assurance that it is being tested properly. It is equally as important that we have accurate sampling methods to correctly represent the material's properties. The sample should be taken at frequencies and locations that most reliably represent the quality or physical attributes of the product. When it comes to sampling, we like to say, bag, tag, and label. Bag. Make sure that the sample is properly secured and in a proper container to ship. Tag. With the AASHTO sampler ID number. Label. Properly label the sample and the ID with as much information as you can. One more note, when it comes to sample custody, the rule is simple. Samples, once taken, always need to remain in the inspector's custody, period. Next, we are going to take a look at several material examples, how they are bagged, tagged, and labeled. Here is an example of a canvas sample bag used to ship samples of aggregates and soils. Notice the filled out sample label attached to the sample. Here is a similar canvas bag designed for smaller 10-pound samples. Here are some aggregate samples that contain a green security seal that is tracked and provides sample custody security. This is covered in more detail in your ACI concrete training courses. This is a 1-quart plastic container used for sampling water-based materials. These are supplied by NDOT. Just contact your state project representative. Here is a 2-quart metal sample container used for sampling PG binders. These are also supplied by NDOT. Just contact your state project representative. Here is a sample of cement. These samples are placed in plastic, then secured in burlap or in a can to protect from moisture damage. This is a cold feed aggregate sample. This sample was obtained in a Ziploc bag. These are 6-inch concrete cylinders that are used to ship TSR samples to the Lincoln Central Lab. You will be learning more about this later. Here is a roadway density core. Notice the paint and the identification on the top of the core. You will learn why this is an important practice later in the training. Here is a 5-gallon bucket. These are typically used for larger samples of powdered materials such as cement, lime dust, or fly ash. This is a picture of the sample ID envelope and an example of the information on the ID card that is inside of the envelope. Here's a sample of reinforcing steel. These are sampled by the heat number of which batch they were produced. The white papers on top are the certifications of material and sample heat number identifications. This is a closer look at the certification for the steel. This will also need to be submitted on OnBase attached to the sample ID number. Here is an example of a handwritten sample ID on the left and one that was printed on the right. It is printed from Site Manager or Ashtoware, which is our project tracking software that is used by the project personnel. Here's an example of some of the precast products that all require certifications: girders, pipe, piling, precast inlets, manholes, or boxes. The precast products that go to NDOT projects come with inspection and shipping reports as shown. Some of them may require minor repairs before shipping and are tagged accordingly by the inspector at the precast factory. Here's an example of a shipping report for reinforced concrete pipe. Here's an example of a shipping report for pre-stressed concrete girders. I think you're getting the theme here. This is an example of a shipping report for metal culvert pipes. Here's an example of sample IDs for concrete cylinders. Notice that it has both the sample ID and it is also written on the cylinder. Okay, this is the last one. I think you get the idea of sampling, bagging, tagging, and labeling. The most important is the custody of samples. Samples, once taken, always need to remain in the inspector's custody, no exceptions. While we are going over the examples of sampling, you heard me mention Site Manager or Ashtoware, it being our project tracking and bookkeeping software. During this training, we do not cover this very important topic because it has its own training for you. The Ashtoware or Site Manager group asked me to mention their group and the training that is offered. This is their team and their phone and email contacts. This group provides training for each NDOT district and for public agencies, cities, counties, and consultant engineering firms. Please contact the support team at ndot.aw projectsupport@nebraska.gov or call 402-479-4760 for both support and to schedule this training for your organization. Now let's move into Module 2, where we will be covering Intro to Asphalt, material types, and asphalt plant operations. We will discuss components of asphalt, types of plants, plant machineries, and types of mixes, including ag production, stockpiles, material types, and plant equipment. Before we begin, let's go over some material definitions. Virgin aggregate is aggregate from a single source and gradation. Blended aggregate is aggregate from multiple gradation or sources, blended in a uniform manner. Cold feed material is the aggregate component of hot mix asphalt that has been blended to the correct ratio prior to the addition of PG binder. Burned off RAP will be added separately. RAP is recycled asphaltic pavement. HMA or hot mix asphalt is the blend of aggregates, performance graded binder, and RAP used to make a flexible pavement, typically produced between 300 to 350 degrees Fahrenheit. WMA or warm mix asphalt is when additives are blended to the HMA to allow for production at lower temperatures, between 225 degrees to 300 degrees Fahrenheit. So what is asphalt? Hot mix asphalt is the blend of aggregates, performance graded binders, and RAP. It is typically produced between 300 to 350 degrees Fahrenheit. Next, you will watch a video on the production of asphalt.
We drive on asphalt roadways most every day. After all, 94% of U.S. roadways are surfaced with asphalt. You may have even seen asphalt being laid on a roadway. Truckloads of hot black asphalt mix are sent to the site to be laid down and compacted. But what is asphalt? What are the parts in that mix that produce a smooth, safe roadway surface to drive on? Let's take a look.
A typical asphalt mix is made up of approximately 95% aggregates, meaning stone, sand, and reclaimed products. The type of stone can vary across the country depending on what type of stone is locally available to producers. The other 5% of the mix is the liquid asphalt glue. Asphalt is refined from the heavy components of crude oil and does not come from tar, which is a coal derivative. In the industry, it is known as binder, since it binds the mix together. Here are some examples of different aggregate sizes that get used in asphalt mixes. These vary in diameter from 1.5 inches all the way down to a fine-grained sand and dust-sized particles. Asphalt roads are designed for many different purposes. A small 2-lane rural road has a different recipe than a major interstate highway. So these aggregates are used in different quantities to meet the specifications for the desired roadway. A stiffer, less flexible pavement can be achieved by using larger aggregates and fewer fines, which creates more stone-to-stone contact. Using more fine aggregates allows for a more flexible pavement because individual stones are surrounded with more binder. This is a core drilled from a roadway that shows a cross-section of the asphalt within. You can see a coarse mix of asphalt in the lower section, or base course, and a finer mix designed for the surface layer. This fine mix is less permeable and keeps water from penetrating down and causing cracks to form. In many states, specifications allow for the use of reclaimed asphalt pavement, or RAP, and recycled asphalt roofing shingles in the permitted asphalt mixes that get placed on roadways. 100% of asphalt millings can be reused in new surfaces. This results in many thousands of tons of recycled asphalt being used in the United States annually. It's actually the most recycled product in the country. That brings us to the liquid asphalt binder itself. It only makes up 5% of the mix, but it is the glue that holds everything together. It is designed to be a strong, yet somewhat elastic adhesive. Polymers and other additives may be used to change its properties so that it behaves differently depending on roadway conditions. These ingredients are heated and mixed together to be placed on the roadway and roller compacted. Once cooled, the new asphalt road surface is ready to ride on in just minutes.
Here is a photo of some RAP, sometimes referred to as millings. The Nebraska DOT is number 1 in the nation for the use of recycled material RAP in pavements, saving both money and precious commodities such as rock, gravel, sand, and petroleum products. Most of the mixes in Nebraska utilize 35 to 65% RAP in the mix blends. Here's a quick summary savings from asphalt pavement recycling efforts of the NDOT over a 12-year time period. As of 2022, we have saved nearly $500 million in aggregate and oil. So let's dig into some aggregate production. This is a photo of a gravel pumping operation at a wet pit in Nebraska. This is very typical along the rivers of Nebraska. In this process, equipment is used to dredge gravel and sand aggregates. The aggregates are screened to size, and the water is then pumped back into the pit. Large fragments are separated out, and the remaining aggregate is conveyed into stockpiles. Now you will see a video of a typical wash plant operation.
In this video, we are looking at a gravel pit here in Nebraska. The aggregate from these pits are used for several applications for the department. They can be found along rivers across the state, and they operate at groundwater elevations. As the pit is dug out, it fills itself back up with groundwater. A tube goes down to the bottom of the pit and sucks up sand and gravel up to the pump house. It travels along this long pipe system until it gets to the screening plant. All of the aggregate enters the top of the plant and travels down the rotating drum. Inside of the drum, the aggregate runs through a series of sieves that separate it by size. Everything sand particle sized and finer is put to the side and kept. Anything larger is returned to a discharge pile. The desired aggregate is run down a series of conveyor belts to a radial stacker. This rotating stacker creates a stockpile, and as the pile reaches the top, it moves to create the next pile. As the camera rotates back to the plant, you can get a better view of the conveyor belts and the rotating drum.
This is a rock quarry, typically found in underground mines. There are 2 large mining operations in Nebraska, near Weeping Water and Fort Calhoun. This ledge rock aggregate is typically mined using explosives and sized through large crushers and screening operations. This is inside one of the mines here in Nebraska. You can see in this picture, metal strips are used to help stabilize the roof of the mine while working inside. The aggregate has been produced. Now what? Let's talk about stockpiles and best management practices. It's imperative to keep stockpiles separate. Aggregates are typically piled into an arc to reduce segregation. Care shall be exercised to avoid segregation and degradation of aggregates or the inclusion of foreign material in the aggregates while the aggregates are being removed from the stockpiles. As written in the standard specification, each aggregate shall be stockpiled separately. This is a dozer pushing millings or wrap into a stockpile. The same management practices should be used for this material, keeping different types stockpiled separately. Now let's take those aggregate wrap and oil binder and look at how it all comes together in an asphalt plant.
Hi, I'm Paul Del Rio from Packy. While driving down a smooth asphalt road, have you ever wondered just how that asphalt mix is produced? Behind me is an asphalt plant where stone, sand, and recycled products are combined with liquid asphalt to make an efficient pavement material.
It all starts at the stockpiles. Each pile consists of a different aggregate ranging from coarser stone down to finer sands. A loader operator hauls stone from the piles to cold feed bins. Each bin holds a different size aggregate. A conveyor running below the bins feeds aggregates into the asphalt plant. The plant operator, working in an on-site control room, can adjust how much of each aggregate size is used in the mix. Usually, the aggregate enters a large rotating drum with a gas-powered burner flame on one end. The aggregate is completely dried by the burner. Once that happens, liquid asphalt is pumped from the heated storage tanks and added to the drum, where the rotation mixes it with the aggregates. Reclaimed asphalt pavement, or wrap, can also be sent to the drum through a separate cold feed bin and conveyor. Using these recycled materials reduces cost and is friendlier to the environment. A continuous plant, or drum plant, uses a drum to dry and also mix the liquid binder and aggregates together. It is the most common type of plant used in the United States. A batch plant also uses a drum to dry the aggregates, but then sends the dried material to a large batch tower, and then to a mixing chamber where the liquid binder and aggregates are combined. Once the asphalt is mixed thoroughly and heated, it is sent up to storage silos. Some silos are only designed to hold material for a short period of time. Other silos are heated and can store mixes for several days. Some plants will use more silos depending upon the number of different mix types needed. Beneath the silos is the loading area. Dump trucks will receive material and then haul it to the paving site. A weight scale is usually located on the loading ramp in order to discharge the correct amount of mix for usage. Once the truck is loaded, the driver is given the signal to transport the asphalt mix to where it's needed for safe, smooth, and economical roadway construction.
Now let's look at the different types of plants typically used here in Nebraska. There are 3 types of drum plants used in Nebraska: parallel flow, counterflow, and double barrel flow. In a parallel flow drum, the aggregate flows in the same direction as the heat. Wrap and binder are added near the end of the process. Just follow the arrows in the diagram. In a counterflow drum, aggregate and hot mix go in one direction, and everything else goes in the opposite direction. The wrap is added behind the flame source, so it is not exposed to direct flame. Again, just follow the arrows in the diagram. The third type is a counterflow double barrel drum. We will show you in a video in the next slide.
The Aztec Double Barrel is a counterflow dryer and a continuous mixer section designed to perform efficient drying followed by thorough mixing. The inner drum is constructed of a large rolled metal plate forming a long cylinder. Formed metal flights attached to the internal surface of the drum to prepare aggregates to be mixed with other ingredients required in the mix. 2 solid steel tires are attached to the rotating inner drum by means of leaf spring-type spokes. 4 trunnions with extra-large railroad car-type bearings support the drum, and 2 thrust rollers keep the drum in place. Virgin aggregate in correct proportions enters the inner drum through a gravity chute outfitted with a flop gate to restrict air entry. The inner drum contains 3 zones, with flights designed for a specific function. Conditioning flights at the inlet end break up any clumps or sticky material. Showering or veiling flights lift and pour the material evenly through the hot gas stream, transferring heat to the cooler, moist aggregates. Material dams assure the showering flights are full to maximize heat transfer to the material veil. Combustion zone flights prevent aggregate from impinging on the flame while spreading the material to maximize radiant heat transfer, as well as to protect the drum shell from damage that can occur from the high temperatures generated by the burner flame in this region. Once heated and dried, the aggregate leaves the drying chamber and enters the insulated mixing chamber. At this point, an infrared sensor measures the temperature of the hot aggregate and sends data to the burner control for automatic adjustment of the burner output. The target temperature for the virgin aggregate will be adjusted relative to the volume of wrap that will be introduced to the outer drum. The hot aggregate transfers heat to the wrap in the outer chamber, driving off moisture as steam. This minimizes emissions because the wrap does not contact the hot gas stream in the dryer chamber. The steam and blue smoke from the mixing chamber are pulled into the inner drum past the burner flame, where the hydrocarbons, or blue smoke, is incinerated. This results in a clear, odor-free stack. The only visible emissions are a steam plume on a cool day, even at 50% wrap. An insulated outer shell promotes efficient use of otherwise fugitive heat from the drying section. The use of the conserved recovered heat from the drying section of the drum translates into fuel savings. The insulated outer drum provides a long mixing chamber where mix ingredients are added to the hot, dry aggregate in an order that allows better temperature equalization and more even distribution of all particles throughout the mix. The double barrel utilizes a sequential mixing order. First, hydrated lime is added when required by spec or mix design, followed by recycled asphalt pavement, known as wrap. Then, liquid asphalt cement, or AC, baghouse fines, and finally, dry additives. The mixing chamber includes rows of mixing paddles mounted on the outside of the rotating dryer drum. These paddles ensure thorough coating of the aggregate. Nyhard paddles mounted to the outer surface of the drum convey and mix the heated aggregate with RAP, AC, and dust. Nyhard belly liners provide a wear-resistant surface for the mix to slide across as it travels through the mixing chamber to the discharge chute. The paddles convey the mix to a sweep-type discharge chute, where it enters a drag conveyor or bucket elevator for transfer to a surge bin or storage silo. The discharge chute includes a weighted flop gate to limit air entry. A temperature sensor at the discharge point signals the mix temperature to the control system.
This is looking into the plant drum barrel. The red dot signifies where the flame would be coming from. As you can see, there are different shapes and sizes of flights within the drum. Each of these has its own purpose, as shown in the diagram: combustion, drying, heating, mixing, and discharge flights. Combustion flights are flat and close to the outer shell. Material moves under the burner flame using combustion flights. As a result, the material is heated but does not make a direct contact with the flame. Drying flights. The dryer flights remove moisture from the material. Heating flights. Once the moisture is removed from the material, it can be heated to the desired temperature. Mixing flights. These mixing flights help with the material handling and flow within the dryer to ensure integration of the material. Discharge flights. Finally, discharge flights move the material out of the dryer. These can vary in shapes depending on the location of the discharge, but often is flat and runs parallel with the dryer. This is a diagram showing drum dryer zones. If you look along the drum, it can be separated into distinct zones. For this diagram, the material inlet would be starting on the left and ending with the discharge zone on the right, where material is then discharged into the silos. Now let's look at all the plant components. This is the plant control house. Inside are the controls and computers. They typically have screens that look like this, as written in the standard specifications. Continuous temperature and time readings shall be electronically recorded whenever the plant is operated. Locations include discharge chute, inside the surge bin every 2 hours, and inside the PG binder storage tank every 2 hours. All of the components in the next few slides are connected to the central drum plant. These photos show the cold feed bins. These are the aggregate bins that supply a calibrated amount of each aggregate proportion for the mix to the plant. This is a top view of the cold feed aggregate bins, showing the different material in each. You do not want the aggregate to overflow from one bin to the next. Make sure the plant loader operator is not overfilling the bins. This is the bag house that is used to filter the exhaust from the plant. The top photo shows the process of replacing the vacuum exhaust bags within the portable bag house. The actual bag house is in the lower photo. Next, you will see a video showing you how a bag house functions. are storage silos. Some are heated and insulated and can hold hot mix for extended periods of time. Others are used for surge storage during daily production. As written in the standard specifications, plants may have surge bins. The material from the surge bin shouldn't differ from the plant material. Also, the surge bin should be completely emptied at the end of each day. This is the slat conveyor. It delivers the HMA up to the storage silos from the plant drum discharge. Here is a slat conveyor that loads the material to the loading hopper instead of large storage silos. This is most typical on portable plants across Nebraska. Here you see the different components of the slat conveyor hopper combination setup. Next you will see a video of loading a truck at the discharge hopper. It usually takes 3 weighted material discharges to fill a belly dump truck like the one shown. Contractors are delivering the hot mix to the paver, and on the return trip they are hauling back millings. This makes it harder to keep truck beds clean. As written in the standard specifications, truck beds or other equipment with which the bituminous mixture comes in contact may only be cleaned with products approved from the department's approved products list. Diesel fuel may be used as a cleaning solvent only at the end of each workday, to avoid contaminating the asphaltic materials. Diesel fuel shall be used in accordance with all applicable environmental laws and regulations. It is also written that the truck bed shall be clean and shall be constructed so that all material remain in the bed while the truck is in transit. Now you will see an overview of a plant operation in Nebraska. There are 5 types of mixes used: SPR, high wrap mix; SRM, special reclamation mix; SPS, shoulder mix; LC, leveling course; and SLX, thin lift and for regular use overlays. First, we will discuss SPR. SPR stands for Standard Paving Recycled Mix. It uses a high recycled mix, up to 55% wrap. It is used for low, medium to medium-high volume roadways. SPR accounts for approximately 60% of NDOT annual tonnage. SPR usage has improved in-place density, increased joint density, has better rut resistance, and increased structural value. SRM is a mix used for deep depth milling and reclamation. It stands for Special Reclamation Mix. Our newest mix, SRM, is a mix used for deep depth milling and reclamation. It stands for Special Reclamation Mix. Used as base mix in lieu of HLSS or cold foam. Typically, it's placed in 4 to 6 inch lifts. It has a coarse high-strength mix, utilizes 35 to 65% wrap, 0.9% warm mix additives are required so that it can compact at lower temperatures. Next, we will talk about SPS. SPS stands for Standard Paved Shoulder Mix. SPS is the mix used only on surfaced shoulders. The SPS mix is very economical, is designed to allow high wrap volumes with a max of 65%. Now let's look at the type LC mix, which stands for leveling course. LC or leveling course mix has extremely fine gradation mix for very thin lifts of asphalt. LC can be placed less than 1 inch thick as a leveling course or scratch course. It has a higher binder content, helps prevent roller bumps, helps resist cracking, and this mix can use up to 35% wrap. And finally, let's look at the type SLX mix. SLX stands for Special Laminate Extreme Thin Mix. SLX can be placed as thin as 1 inch and up to 6 inches thick. Typically, it contains 20 to 35% processed wrap. SLX is our most versatile mix and is used in many applications. This is our most popular mix and represents about 40% of our mainline tonnage. Now let's move into Module 3, where we will be covering laydown, paving, and compaction, including milling, surface prep, tack, delivery, material transfer vehicles, screed components, notched wedges, beveled edges, intersections and drives, and compaction processes and importance. Now let's go out on the road. Milling, or sometimes referred to as cold milling, is the process of partial or full removal to a specific depth of asphalt surface. Most of the removed material can be processed and become recycled asphalt or wrap. Generally, the road is milled 1 to 4 inches as specified in the plans. Next, I'm going to show you 3 short videos. The first one is showing you a milling machine making its first pass, milling half of the lane width.
This is the milling operation. On this project, they're using a 7-foot mill to take out the centerline section, and then a second 7-foot mill to take out the outside edge. You're loading this into a belly dump truck. Occasionally, they'll also load into end dumps.
Now you will see the milling machine making its final pass of the lane width.
This is the second mill of the operation. You can see that the trench is already there from the first mill, And he's just taking out the remaining about 5 feet, loading it into another belly dump truck. And immediately behind the second mill, they have a motor grader working, who's scraping off any of the stuck material to the concrete. Part of the requirements of this job was to remove all the asphalt off the concrete. So the motor grader is getting anything that was still stuck the mills missed.
This last video shows the brooming and cleaning up after the milling operation.
After the motor grader scrapes the pavement off and makes part of the trench cut, then the brooms come along and clean up the pavement, starting with the center line joint and working their way outward to move all the excess material out toward the ditch.
Once the surface is milled and broomed clean, a tack coat is sprayed. Here are a couple short videos showing how the tack truck applies the tack, which is called an emulsion. It is basically half water, half oil, and emulsified together with soap to get the oil and water to blend.
After the pavement is thoroughly cleaned, the tack truck shoots emulsion on the pavement. Giving full coverage, so we get a nice surface for the asphalt pavement to adhere to. In this instance, you can see he's got a couple of nozzles. They're starting to get plugged, and they need to adjust them. Here the tack truck shooting an extra shot of tack along center line joint to make sure we get good seal there and improve the coverage and help with the joint density.
After we do all this prep work and the tack is applied, we need to keep the project and paving surfaces clean. As written in the standard specifications, before placing the bituminous surfacing, the contractor shall clean the surface to be treated with mechanical brooms or hand tools as necessary to remove all vegetation, loose surface material, dirt, mud, old crack sealant, unsuitable bituminous or other deleterious material. Any surfacing material not securely bonded to the surface shall be removed. Material cleaned from the surface shall be swept to the sides or windrowed as required, and removed by the contractor at no additional cost. Now let's talk a little bit more about tack coats. Tack coats are a vital component of an asphalt pavement structural system as they bond the multiple asphalt lifts into one layer. Poor tack coat applications result in poor bonding of the asphalt layers. This is an image of a milled, cleaned, and tacked roadway surface. When tack is sprayed on the roadway, it should be wet, shiny, and brown with full width lane coverage. After a short time, the tack will turn black. This is called broke. The surface will be dark in color with less sheen. The contractor will be ready to lay asphalt once the tack has broke. As written in the standard specification, tack is applied after existing surfaces has been prepared and between each successive layer of asphaltic concrete. The tack will be applied in accordance with the requirements of Section 504. It is common for contractors to place tack far in advance, often a day ahead of laydown. This reduces waiting for the tack to break, increasing productivity. Visually confirm that the tack is ready to go. Perhaps the tack will need to be fogged the next day due to tracking or wear. Fogging is when it's freshened up with a light spray of tack. Full lane coverage and a slight overspray of the lane width is necessary. Next, you will see a video of how contractors apply tack with a spray wand. Tack should be sprayed 1 to 2 feet wider than the intended laydown surface as seen here. Also worth noticing, the truck is driving through the tack to deliver the load, lessening the tack coat with the truck tires, something to watch as a laydown inspector. This sometimes means a light fog or tack coat may be needed before proceeding with laydown of material. In one of the earlier slides, I talked about the tack material breaking. The image on the left shows the tack that has not yet broke, and the image on the right shows tack that has broke. Notice the brown versus the black color. Here the contractor has sprayed tack on the next laydown location. The surface is ready to go once all free moisture has evaporated or drained off the surface. As written in the standard specifications, asphaltic concrete shall not be placed over emulsified tack coat until the emulsion has broke and all free moisture has evaporated or drained off the surface. This image of tack over Portland concrete pavement is showing tine marks and grooves. Trucks and traffic can pull out small fines, often leaving not enough tack coverage. The contractor's tack truck needs to apply a heavier application of tack to these surfaces. As written in the standard specification, the rate of application shall be adequate to bond the new bituminous layer to the existing surface. This shall be from 0.10 to 0.20 gallons per square yard when applied to existing or milled surfaces, and from 0.05 to 0.10 gallons per square yard when applied to freshly laid asphaltic concrete. The roadway is prepped. Now loads of asphalt are being delivered to the project. Not all projects are required to tarp their load depending on the haul times. During the cooler weather or during the longer haul times, the contractor's delivery trucks are mandated to use a tarp, no exclusions. As written in the standard specifications, all trucks shall be equipped with a suitable and waterproof cover. This doesn't mean that they have to be utilized, but must have accessibility so that the asphalt doesn't cool. This is a material transfer vehicle, or better known as an MTV. As written in the standard specifications, material transfer vehicles are authorized. Before crossing any bridge, these vehicles must be unloaded to a weight approved by the NDOT Bridge Division. These units can be heavy. Care needs to be taken on structures, such as bridges, not to exceed the rated gross vehicle rate. MTVs are important for transferring asphalt into the paver hopper for paving. MTVs can also help reduce segregation, bumps, and tack wear due to traffic. Here is another MTV in the paving train. The discharge goes into the hopper where the state inspector is checking temperature. The MTV will pick up and deliver into the paver hopper, the last piece of machinery in the train. Behind the paver is the newly laid asphalt with rolling and compaction operations. Next you will see a video that is using another type of material elevating equipment called a pickup machine. These can be used for shoulder paving.
In this video, we are looking at a standard pickup machine on a bridge membrane overlay. A pickup machine is directly hooked up to and is driven by the paver. After the belly dump drops its asphalt load into a windrow, the pickup machine can load the asphalt into the paver. In front of the machine, you can see the side augers pushing the asphalt to the middle for the slat conveyor belt to pick up. The slats are offset from the ground to prevent scarring the bridge membrane. The asphalt rides to the top of the conveyor and is dumped into the paver hopper. The advantage of using a pickup machine is to allow for continuous paving to prevent transverse bumps that form when a paver starts and stops while waiting for the next asphalt truck. The pickup machine also helps to evenly distribute heat more than having just the paver by itself.
This is a flowboy, or a live bottom trailer, pulled behind a semi. These trailers can haul about 25 tons of asphalt in a single load. The discharge is from the rear of the trailer. The asphalt will dump directly into the mobile transfer vehicle, or the hopper of the laydown machine. These trailers work well for placing asphalt in drives, intersections, and patching operations. Here is an image of a flowboy trailer, also known as a live bottom truck, dumping directly into the MTV or into the hopper of a laydown machine. This is a belly dump delivery trailer. During this process, the hopper will discharge onto the surface of the road. Then the MTV will pick up the asphalt and place it into the hopper of the paver. This delivery system can create a temperature variation where the asphalt is hotter at the bottom of the load. The way the contractor discharges the load can help lessen the temperature variation. Next, you will see a short video of paving a shoulder by dumping a windrow onto the main line and using the MTV to feed the paver on the shoulder. Take note the kind of cleanup that needs to be done while the material is still hot.
Behind the paver, paving the 9-foot shoulders on new grade. Skid loader's cleaning up the roadway after the MTV picked up most of the material. There's always crumbs that they can't collect.
This image shows a belly dump being discharged onto the surface of the road being paved in front of the MTV. It's important to have enough trucks and asphalt production to have continuous laydown operations. This helps to lessen roadway bumps due to start and stop operations. As written in the standard specifications, the delivery of asphaltic concrete shall be scheduled to allow continuous laydown operations. Now you will see 3 short videos with a belly dump. The first 2 videos will show how to pave a new shoulder on the roadway. The belly dump will place the windrow onto the middle of the lane, while the MTV picks up material and feeds it into the paver. The third video will show a typical mainline paving operation and normal procedures for a belly dump on the surface of roadway to be paved.
The bottom dump truck is dumping the windrow on the pavement. The MTV is loading the paver as they progress forward in tandem to collect more material and continue paving on this bottom lift of shoulder full depth construction on new grade. can see the vertical edge of the existing concrete pavement has been tacked. Belly dump truck getting ready to unload in front of the paver. As the paver approaches, they'll start dumping the truck. So the paving operation can keep moving. They always back the truck up over the previous windrow, so they're mixing new hot material with the older stuff that might be a little cooler. Dump just in time for the paver to approach, so the paver can keep moving.
Next, we will discuss the paver. The components of the screed include toe point, screen arm, screed depth crank, pivot point, screed plate, screed angle of attack, strike-off plate, and auger. When the toe point rises, it will increase the depth under the screed plate. Doing this will increase the distance between the toe point and the screed plate. This is a picture of the augers that are located at the back of the paver, just before the screed on the left. Contractors can and will add additional augers and extensions when the lane width increases, according to the plans. The thing to remember here is that the contractor understands and is proficient at placing the auger extensions to minimize the stopping and starting process of the paver. A lack of material ran through the auger process can leave a bump or dip in finished asphalt surface. As written in the standard specifications, the paver shall be equipped with a distributing auger or other acceptable devices that will distribute the asphaltic concrete evenly across the entire screed width. This picture shows the signs of wear on the auger. The angularity of the aggregates in the asphalt can create wear on the equipment components. When the augers are worn down, it can cause segregation and uneven distribution over the roadway width. This is something to watch for during laydown to be sure that the asphalt is reaching the outer limits of the screed. This is an image of an auger sensor. It behaves like the auger paddle. Some paver operators don't like this sensor due to the polymer strings that can get gunked up. When this happens, the sensor will not operate as well. The sensor's job is to send information to the paver to know the height of the material in the augers. Overfilling the augers can be as challenging as underfilling the augers. It is important to have a steady flow of asphalt across the roadway and paver width. Here you can see the change in asphalt that has been laid on the road. This occurred because they weren't up to the correct temperature on their screed heater. If this happens, they should stop for a few minutes to allow the screed to heat up to the appropriate temperature. The reference system, also known as a ski, needs to be 30 foot or longer. It should be used near the center line of the roadway and shall be used to place all layers. The only two exceptions are for the final layer, which is done with a joint matching shoe, or for shoulder work. Here the contractor's paver operator is doing a depth check of the asphalt mat before being rolled. Here they are using a steel bar with an adjustable marker, which is set to the desired thickness. As a laydown inspector, these depth checks are important to help you control the tons per station, so that the project lays the correct amount of asphalt and does not run too far over or under the required production tons. Here we can see the contractor using a 10-foot straight edge with a level on top of the mat to check for slope. Most roadways slope to the shoulder for water runoff. Some roadways have curves that require much more slope. Make sure to check the plans for the information about slope requirements. Here are some important specifications about laydown that you will also need to know, as written in the standard specifications, placement operations. Asphaltic concrete used in constructions of sections having uniform width, including the surface layer or surface shoulders, and the surface layer of the intersections and driveways, shall be placed with a paver or finishing machine. The surface lift of asphalt shoulder shall be placed with a paver. Lower lifts of asphalt shoulder may be placed with a side delivery machine. In deep, irregular, or narrow sections and in flume, ditch lining, island noses, or where it is impractical to use mechanical finishing machine, the contractor may use other approved methods for spreading the mixture. Dumping bituminous mixture on the pavement which is not to be resurfaced will not be allowed. Please note, top lift is always placed with a mechanical paver. At the end of each day's paving, we must place a wedge to smooth out temporary transition, as written in the standard specifications. The roller shall pass over the unprotected end of the freshly placed mixture only when the placement of the layer is to be discontinued. When placement is discontinued, a wedge of asphaltic concrete, feathered 3 feet in length for each inch of layer thickness, shall be placed at the end of each lane. At the end of each day's paving operation, if not at the end of each lane, the contractor will need to break bond with the tag. Use dirt, sand, paper, or plastic to break the bond. Do this so that later a motor grader or bobcat can be used to remove the header. Also remember that the slope coming off the headers should be feathered 3 foot for each layer of mat thickness. Inspectors should never leave when building a header until completion and confirmed safe for vehicle travel. Here is another type of wedge. It is constructed along the center line. It is called a notched wedge joint. The notched wedge joint has a safety and production advantage over a standard joint. Contractors can continue paving without an edge drop-off. This also improves density and decreases permeability. With less water seeping through the joint, this type of joint improves long-term asphalt pavement performance. A notched wedge reduces the center line drop-off to less than 2 inches. This helps save cost for traffic control. We don't need to have any cones or barrels at center line with the notch wedge because the drop-off is less than 2 inches. Also, this makes for less hazard for the traveling public. This is what it looks like after it is constructed. This provides a better transversable geometric at center line. This also allows the contractor to continue working in the same lane. They don't have to back up and catch the other lane up at the end of each day's paving. This is another type of wedge. It is on the outside of the lane and is called a beveled edge. This provides a taper on the edge of the paving that has been shaped to 30 degrees. This provides a smoother transition on the outside of the pavement for the traveling public. If someone happens to have a tire go off the edge of the road, it is easier for them to return to their lane. This is how it is formed, using a shoe inside of the screed. Here are some tips to remember when inspecting beveled edge paving. The rolling pattern should be watched closely to ensure there is a 30-degree shape. Compact once with a breakdown roller. Avoid contact near the top of the bevel during the intermediate rolling, and then complete the rolling with the finish roller. Next, you will see a video showing the paving of a beveled edge and the first pass with a breakdown roller. Let's take a look on how intersections, drives, and irregular areas are paved. Here, a contractor is raking the material into the intersection. Drives and intersections can be laid with equipment other than the paver, but the paver must be used on the top lift. Most contractors will pave these during the placement of the lane. Next, you will see two videos. The first will show how an intersection and main line are joined in the paving operation. In the second video, you will see them compacted together while both mats are still hot. In this next section, we will look at compaction. It is common to see the rollers this close behind the paver. Okay, maybe slightly too close, but it is necessary to optimize compaction. The roller needs to get on the asphalt when it is the hottest, right behind the paver. This roller is the breakdown roller. It typically operates within 500 feet of the paver. It operates like it is somewhat connected to the paver with a string. Here is a close-up photo showing the roller drum and the scrapers. As written in the standard specification, all roller wheels shall be smooth and free from defects that would mar the surface of the work. Adjustable spring scrapers shall be fitted to each roller to scrape in both directions. This picture also shows the drum scraper. Be sure to check the condition of the rollers before use. Next, you will see a video showing the breakdown roller. Notice how it stays very close to the paver and makes long gradual sweeping turns, making sure not to tear the loose mat.
In this video, we are looking at a roller about to start its first pass on a cold morning. The asphalt is being placed on a milled concrete surface on a bridge approach section, moving away from the bridge. The paver's screed was set to 0 and gradually opened up to the design height as it moved away from the starting point. The roller must start making its first pass quickly due to the thin asphalt layer and cold temperature, causing the asphalt to cool. The roller backs all the way off the asphalt to adjust its direction before returning to the mat to prevent tearing. In the second half of this video, we see another roller completing a forward pass and then starting a return pass. It takes a gradual turn to prevent mat tearing. It also avoids coming within 6 inches of the outside of the lane.
Here is a close-up of the drum, looking at the vibratory part of the roller. Frequency is how fast the drum is vibrating. Amplitude is the measurement of how far you are driving the drum up and down the asphalt mat. Note, if the aggregate is breaking, the amplitude may be set too high. Generally, the contractor likes high amplitude for best results. The manufacturer's recommendations shall be made available to the engineer 2 weeks prior to placement. As written in the standard specifications, the frequency and amplitude of the vibratory rollers shall be adjusted to the manufacturer's recommendation for thickness of layers being placed and the speed at which the roller is being operated. Here is the exact way that a joint should be compacted. As written in the standard specifications, when paving adjacent to the previously placed lane, or when placing the top layer of surfacing adjacent to the existing pavement or curb, the last pass of the roller, which is the full roller width, is entirely on the freshly placed material, shall be kept approximately 6 inches from the existing facility. The final pass of the roller shall then be made over the remaining uncompacted 6-inch strip, tucking the material into the joint. And one last section I need to cover. This occurs maybe once or twice a year on a paving project. It is pretty rare, but is a possible issue that can happen. Some asphalt mixes have what we call a compaction tender zone. Different mixes on different projects will behave differently. You must detect early on if your mix has a tender zone. This is done by monitoring the rolling operation with temperature gauges, density gauges, and most importantly, your eyes. This is what it will look like. This picture shows the high spots bladed off after the first lift. These bumps occurred at the underlying joint from the concrete below. Here's what basically happens. It is called material rollover. When going over existing joints, the mix will tend to catch on the joints or cracks and leave a bump. Once this occurs, it will worsen with each pass. This bump can also leave a tear in the mat. There is a solution. The use of leveling course mixes can help with some of these problems. These mixes are known as the type LC or SLX, also called scratch course. These are used for overlays on concrete or severely patched roadways. Leveling course's most common application is for paving over concrete or pavement with heavily patched asphalt or composite pavement. A leveling course on these types of foundation can improve the smoothness of the completed roadway. It also helps keep cracks from being transmitted up from the foundation during the laydown. You can also experience a longitudinal crack in the direction of the paving and rolling from over-rolling the tender zone. Mostly, you will see this in the center of the lane. This is generally because the contractor didn't overlap the rolling. This can lead to obviously poorly compacted sections of the pavement and ultimately leads to poor pavement performance. Also, with high compaction temperatures and too fast of roller speed, transverse rippling and tearing can occur. Remember these 3 rolling times: breakdown rolling, intermediate rolling, and finish rolling. During the breakdown rolling, the oil is still very hot and acts as a lubricant that helps the initial compaction and orientation of the aggregates to occur. This type of rolling is accomplished by always keeping a double steel drum roller right behind the paver. During intermediate rolling, the oil is starting to cool and becomes more sticky. It can now hold the increased densification of the mat together. Double steel drum rollers, pneumatic rollers, or combination rollers are used during this stage. During finish rolling, the oil is now almost solid. This is the stage when the roller marks are taken out without adding additional ones, and a slight increase in density is obtained. Double steel drum rollers or combination rollers are used during this stage. Now let's take a look at a video that puts all of these operations together.
We've all driven on a smooth asphalt roadway, but just how is a quality asphalt mat constructed? It's made possible by a series of machines called a paving train. It requires a set of specialized equipment and a skilled crew to operate them.
Before paving begins, the underlying surface must be properly prepared. This may involve milling the old surface and sweeping away excess dust and debris. Applying a fresh tack coat layer helps create a tight bond between the new and existing pavements. With the surface ready for new asphalt, the paving train can mobilize. This begins with dump trucks that haul the mix from the plant to the paving site. On larger paving jobs, the truck will sometimes dump the asphalt into a material transfer vehicle, or MTV, first. This is useful for making the mix more uniform and allows the paver to operate more continuously, since it doesn't need to stop between truckloads. The MTV or dump truck unloads the mix directly into the paver. This is the machine that actually lays the finished asphalt surface onto the roadway. A conveyor and augers are used to evenly distribute the asphalt mix before it exits the paver at the rear. The asphalt is applied to the roadway by the screed, which is a plate that can be adjusted up or down in order to produce the specified consistent pavement thickness. As the paver applies the asphalt to the roadway, it maintains a constant speed in order to ensure a smooth road surface at the proper thickness. The screed also provides the initial compaction to the pavement. A paver will typically need to make multiple passes in order to cover the entire roadway, depending on the number of lanes to be paved. Once the paver applies the asphalt to the roadway, the final step is to compact the material using rollers. The roller maneuvers in a specific pattern of passes to ensure that the entire surface of the mat is being compacted uniformly. After reaching target compaction, the roadway can receive traffic within the same day, all due to the efficiency of the asphalt paving train.
This completes the first half of the asphalt field technician training. Remember to fill in your answers to the pre-test as you are watching the training. It will help you better prepare. Next, you will watch the second portion of this training, which includes modules 4 through 7.